So in this lecture, let's study about storage classes in C. The storage classes in C language decides scope of a variable, it decides visibility of a variable or a function, and lifetime of a variable. Scope, visibility, and lifetime are features of a variable. So these features can be modified by using storage class specifiers. Let's see some of the storage class specifiers which are available in C. There are two widely used storage class specifiers. One is static and another one is external. So now let's first understand about the static storage class specifier. So we'll understand this by using an example. Alright, so here I have a function called main. So now let me create one more function called my function, which doesn't return anything and it doesn't take any arguments. All are void. And now let's give the prototype of this function. So let me end this statement with semicolon. So now the goal of this program is to count how many times my function 1 is called from the main function. So I'm going to call this function from main couple of times. Let's call here, and after that let's call one more time, and I'm calling my function 1 4 times. And this function has to print how many times this function gets called. For that, in order to count, let me use one variable. So let me call it as int count. So now let me initialize this to 0 and let me increment the count by 1, count plus 1. So whenever this function is called, count will be incremented by 1, and after that I'm going to print that count value, printf. This function executed %d times. So now after that, let me give the argument, that is this variable name count. So goal of this application is just to print how many times this function gets executed. So now let me run the program. And here you can see that. So what's happening here? So everywhere it is saying that this function executed one time, right? But our goal is to count how many times this function gets executed, right? So first analyze what's happening in this program. Let's start with main. So execution starts with main, right? So inside the main body, so we have first there is a call to the my function 1. So control comes here, right? And when it comes here, a local variable is created and initialized to 0. And after that, 0 is incremented by 1 and then the value is stored back into the variable count, right? The count is 1, right? And printf prints the value that is 1. That's great. And after that, this function returns. The moment the execution control goes out of this function, what happens is this local variable dies. The memory location associated with that variable is removed. The value is lost. So this variable loses its existence. And then function returns to main again, and after that there is one more call to the same function, and the control again comes to the main function. Again the variable is created and it is initialized to 0, and again that 0 is incremented by 1, and again it prints 1 here. So it happens like that. So but our goal is to count, right? We don't want count variable to die. We want this variable to hold its last value, right, across multiple function calls. So how to achieve that? So this problem can be easily solved by removing this variable from local space and moving that variable to global space. So now the count variable is moved to global space. So global variables will not die until you terminate the application. So their lifetime is until you terminate the application, the global variable will be there, and their scope is visible to all the functions. Let's try once again. So now the problem is solved, right? The function executed one time, two times, three times, four times. So it is now correctly printing. So this is what we expected. But there is a small problem. The problem is now you made this variable public. So now this variable can be modified by any function in the program, right? So even this variable can be modified by some other file of the project. So this is completely public to all the functions of your project. That is not good. So now our requirement for this program is we want a global variable that is private to a function. So we want private variable that does not lose its existence even if the execution control goes out of the scope of that variable. So in order to achieve this requirement, that is, we want a global variable, but it should be private to a function. So this can be achieved in C by using a storage class specifier called static. Let's see how to use that. Let's go back to the function. Now again, let's remove this variable definition from here and let's again move that into the local space. So use the static keyword here, static int count. So now count is a global variable, but it is private to the my function one. So now let's run this program. Let's see how it goes. And here you can see that we got the expected result. But in this case, this count variable is accessible only from my function one, not from other functions. And also remember that this variable will not die even if the execution control goes out of this function. The scope of this variable is now global, but visibility is only for this function. So we'll understand more about static storage class specifier in the next lecture. Welcome back to the lecture. So now let's see some more use cases of static storage class specifier. So a C project can be a collection of multiple source files, right? A project may be having many source files such as, let's say, file 1.c, file 2.c, file 3.c, etc. So now some files may be written by you and some files may be written by someone else who is part of the project. In this case, a static storage class specifier can be used to manage the visibility of the variables across various files effectively. Let's see how. Alright, so now let me demonstrate another usage of static. So when a project contains multiple files. So here I have a project. The project name is static_1 and it has one file that is main.c. Let's create another file, new file, and let me give the file name as, let's say, file1.c. So in file1.c, I'm going to create one function, a void function. Let me create a function here. Void, let's say, file1 underscore my function 1. So an empty function. Let's go to the main.c. And here, what I'm going to do is I'm going to create one global variable. Let's say int private data. So now let's say this data is private to the main.c. So now let me initialize this data here. Let me initialize that to, let's say, 100. And after that, let me print that data. And after that, what I'm going to do is I'm going to call this function from main. So remember what I said was this data, which is type of int, is private to the main.c. So that means main.c expects that this data should not be modified outside the scope of this file. So but in file1.c, we can modify this data, right? So what I can do is I can simply change its value. So let me change it to 900. That's possible because this is global to the whole project. That means its visibility is to all the files of the project. Let's try to compile. Let's see what happens. Here we may get a couple of errors. So let's see what are the errors. First of all, first compiler tried to compile main.c and it met with an error here. implicit declaration of function. So basically compiler is saying that it couldn't able to find the declaration or prototype of this function, which is defined somewhere else in the project, right? So that's why it's our duty to give the function prototype of this function. Let's copy this name and let's copy this and go to the main.c, go to the global section here. And just to make the compiler happy, so let's give the prototype. This is a prototype. Let's try to compile. Let's see what happens. So main.c compiled fine, no problem with the main.c. Now the problem is in file1.c, where the compiler is complaining that this is undeclared. So that's why you have to give the declaration now, not definition, remember, because it is already defined here, right? So you have to declare that it is there somewhere. We do that by using extern. Extern int private data. So this is a declaration. Before modifying that variable, so we have to declare the compiler that it is there somewhere else in the project. After that, let me print this printf statement once again after this line. Let me try to compile. Let's see what happens. Right, so here it is. So first the value was 100, and after that you called this function which is there in file1.c, and file1.c can simply extern that variable and it can modify it, right? So that's why when you do this printf, it printed 900. That means the value is modified. But main.c wanted no one to touch that variable outside the scope of this file. So that means if main.c wants to keep this variable private to this file, then it has to use the static keyword here. So now this is accessible only inside the scope of this file, that is main.c, and it cannot be accessed from outside the scope of this file. Let's try to compile. Let's see what happens. Here you can see that compiler is not letting file1.c to modify this value. It is throwing error. The project compilation is not successful, right? So it is saying that undefined reference to this data. In real project implementation, let's say main.c may be implemented by you and file1.c may be implemented by some other developer. And if you want to put such restrictions, then you can use the static keyword. So that means this is kind of imposing privacy to your global variables so that it should not be modified randomly across multiple project files. So that's one of the important use case of static keyword. So here, if you want to compile this project successfully, then you should first remove this because static variables cannot be externed. So that's why you have to remove this and you have to give up this. Otherwise, project will not compile successfully. So static keyword can be used with functions, and we'll see that in the next lecture. Okay, welcome back to the lecture. So now in this lecture, let's see how static keyword can be used with functions. So now let's say we have two files, a main.c and file1.c. And now let's say I create one function in main.c. Now the function name may be, let's say, void change system clock. So now let's say this function takes the argument system clock from other functions. So don't worry, you'll learn more about functions later. So what this function does is it actually takes system clock value from other functions in this variable, and then it uses this variable to change the system clock. Let's just print system clock here. So now let me just print a message, system clock, let's say change to. Let's print this value. So now let's say for main.c, this is very critical and very important function, and this function should not be called from other files. The developer who wrote this function wants only functions of main.c should call this function. So functions outside the file main.c should not call this function. But if you leave this function like this, So any function of the project can call this function and it can change the system clock and thus causing problem to the application. For example, in this case, we have file1.c and the function of the file1.c can call this function. So it can just call this function, no issues at all. So it can call with, let's say, 0. Let's say it wants to freeze the system clock. So this is perfectly fine. So all you need to do is just give the prototype of this function right over here and just call that function. You can even use the extern keyword here because you are actually calling a function which is implemented outside the scope of this file, right? So you can even use the extern with this function prototype. So, but extern is usually assumed here, so you need not to use the keyword extern actually. So it is assumed. So now this code works perfectly fine. So now if I run the code, what happens here? Here you can see that there are no errors, right? So file1.c simply called that function and it changed the system clock, which main.c doesn't want to happen, right? So if main.c wants to protect calling this function outside the scope of this file, then you have to use static keyword here. So this is a static function, or it's also called as a private function of the file main.c. So only functions of the main.c can call this function now. So no functions outside the scope of this file can call this function. All right, so let's try to compile. Let's see what happens. The compilation is not successful, right? So the compiler is saying that undefined reference made to this function. So the compiler is not letting file1.c to compile successfully. So that's an alert for the developer of file1.c to understand that he should not call change system clock function because it's a private function. And that's how privacy is imposed in C. So that's about usage of static. In the next lecture, let's explore about another storage class specifier that is extern. And I'll see you in the next lecture. So let's understand about extern keyword. So we actually already used this extern keyword in our previous example, right? But let's understand some points about extern keyword. So extern storage class specifier is used to access the global variable which is defined outside the scope of a file. So extern storage class specifier can also be used during the function call. So when the function is defined outside the scope of the file. Here, in this case, actually mentioning extern keyword is not compulsory. It is optional, as we saw in the previous example. So extern is assumed when you try to call a function which is outside the scope of that file. And now let's move forward. The keyword extern is relevant only when your project consists of multiple files and you need to access a variable defined in one file from another file. So it makes sense only when you have multiple files. Otherwise, you need not to use extern. So extern keyword is used to extend the visibility of a function or variable. So that's about extern. And in the next lecture, we'll see some more concepts of C, and I'll see you in the next lecture. Hey, welcome back to the lecture. So in this lecture, let's explore about ASCII codes. The American National Standards Institute, which developed ANSI, also developed the ASCII codes. So ASCII stands for American Standard Code for Information Interchange. So by using ASCII standard, that is ASCII standard codes, you can encode 128 different characters which you encounter in your day-to-day life. That's why to encode any ASCII character, you just need 7 bits. So because there are 128 characters and one unique code will be used to represent a character. So in order to know the ASCII codes for the characters, you have to refer to the ASCII table. So this is the ASCII table which I got from internet. So now here you can see that. So these are, uppercase alphabets, right? And these are the respective ASCII codes for them in decimal. So these are actually the lowercase letters, right? And these are the respective ASCII codes. So not only for English alphabets, you can also get ASCII codes for special characters like space, double quote, hash, ampersand, etc. You also get ASCII codes to represent numbers from 0 to 9. And also, you get ASCII codes to represent some special characters such as carriage return. And this is for backspace. This is for horizontal tab. So like that. So these are the codes for the keys which you find on your computer keyboard. So let's take an example. Let's say I want to represent these characters inside the computer memory. So I want to store the word apple in computer memory. For the machine, everything is number, right? So machine doesn't recognize it like A or P or L or whatever. So for the machine, everything is number. So basically what we are going to do is we are going to store the respective ASCII codes of those characters inside the computer memory, right? So that's how we process the characters, strings, alphabets, etc. All right, so now let's do one exercise in order to print the string apple. First, let's represent the word apple in our program. So first of all, we know the ASCII codes. So now let's use variables to store those ASCII codes. Let me create a variable char a1. So a1 means, let's say, alphabet 1 is equal to, let me store the ASCII code. The ASCII code of A, that is 65. A2 alphabet 2, ASCII code of P, 112. So A3 is 112. Char A4 is equal to L is 108. Char A6 is equal to 58. A7 is equal to 41. So I think it's very hard, right? So this procedure is very hard that we should refer to the ASCII table and we have to pick the ASCII code. So instead of doing this, there is one shortcut method. So this is very chaotic, right? So you have to refer to the ASCII table, get the code and include that in the code. It is actually a very tedious process. There is one simple method. That is, instead of writing 65, just write A and give single quotes. So write your alphabet inside or character inside the single quotes. So compiler will replace this by 65. So that is easy, right? So let's do that instead of writing all these codes. This is very much easy, right? So A1 holds not A, it holds 65, the code of A. So that will be done by the compiler at the background. So you need not to worry about that. Let's printf, the string is. We want to print like characters, not like numbers, right? So that's why we have to use %C as the format specifier. So that's why you have to use %C, not %D. %C/n, and let's print A1. Let's see how it goes. Let me just run this. So it printed A. %D, then it prints integer. It prints 65, right? This is a value which is stored in A1, right? So that's what printed here. But if you use %C, it prints, the format will be changed to ASCII. If I want to print all these variables, so I have to repeat this, right? So %C, C, %C, %C, so like this. So there are 7 format specifiers. And let me write A2, A3, A4, A5, A6, A7. Let's run. So it printed apple. So you can even remove this space here. Now let's run. So that's how you actually store the characters in your program. All these codes can be replaced by one line by using arrays. Like for example, I can do this. Char a of array is equal to apple. I can do this. For this, we have to explore arrays. So this we will see when we cover the sections arrays and strings. So that's how you store the characters, and that's how you print the characters. And I hope you get the idea about ASCII and ASCII codes and about this format specifier %C. And if you have any questions, please don't hesitate to ask, and I'll see you in the next lecture.